Here we're going to try and integrate natural log of x. And you might wonder why this is in the integration by parts section. Well, we're going to learn a bit of a trick which helps us integrate natural log of x. So remember, to use by parts, we need to have the product of two terms. So the trick that we're going to learn is that actually we're going to write this as 1 times by log x. And then we're going to use the by parts formula on this integral. So to use the by parts formula, we need to decide what's u and what's v. And we're also going to need to know du by dx and dv by dx. So our terms are 1 and log x, so we could add either u equals 1, and in that case dv by dx would be log x, or the other option would be to have u as log x, and in that case dv by dx would be equal to 1. Now it's quite clear which way around this has to be. dv by dx can't be log x, because if we wanted to find out v, we would have to integrate log x, which we are trying to find out. We don't know what that is at the moment. So that tells us that u is going to have to be log x and dv by dx is equal to 1. If you were using the LATE acronym, then 1, the term 1 is what we call algebra. It's a polynomial and or a power of x, and we've got log x, which is L. So remember, whichever letter comes first in LATE is what u is going to be equal to. So L comes before A, so u is going to be the log term. So du by dx is equal to 1 over x, and if we integrate dv by dx to get v, we're going to have x. And it's worth checking at this point. Remember, we need to be able to integrate v times by du by dx, which we can do. So if we use the formula on the left hand side, we're going to have u dv by dx, which is just log x, equals uv, so x ln x, minus the integral of v du by dx, so x times by 1 over x. So we're going to have x, natural log of x, minus the integral of 1 dx. So that's x, natural log of x, minus x. And if we go back to our original question, we had a definite integral with limits of x equals 1 up to x equals 2. So at this point, we can deal with the fact that we've got limits. So we can just put our integral into a square bracket to show that we're going to sub in the limits of 2 and 1, and we know that the integral is x log x minus x. So if we sub in the top limit, we're going to have 2 log 2 minus 2, and then we need to subtract what do we get when we sub in the lower limit. So if we sub in the lower limit, we're going to have 1 times by log 1 and minus 1. So let's expand this second bracket out. So we're going to have, well, log 1 is just 0. So we're actually going to have minus 1, which is plus 1. So our answer is going to be 2 log 2 minus 1.